Okay, simplifying rational expressions. This video hopefully will help you to be able to describe the different ways to simplify rational expressions. First of all, a rational expression is an expression that can be written as a fraction in the form of a polynomial over a polynomial. Like this example right here. We have a binomial being divided by a binomial. A way to simplify this expression, rational expression, is to try to factor out the numerator and denominator so we can see if there are any common factors that can cancel out, just like reducing a fraction, or simplifying the fraction. Okay, so first let's look at the numerator. We have a 6x plus a 12. Out of these two terms, they have a common factor of 6. So we can factor out a factor of 6 in the numerator, basically using like the reverse of the distributive property. So it will look something like this. 6 times the quantity x plus 2. And the denominator, there's no common factor, so it just stayed x plus 2. So we have a x plus 2, or a factor of x plus 2 in the numerator, and a factor of x plus 2 in the denominator. And anytime we're dividing and we have common factors, we can divide those out. So I'm going to cancel out or divide out the x plus 2, making that 1, because x plus 2 divided by x plus 2 is 1. So that leaves us with 6. Okay, so this would be our answer right here. So this rational expression simplifies all the way down to just a whole number 6. Okay, another type of rational expression could be a monomial being divided by another monomial. So a single term polynomial divided by another single term polynomial. So once again, we want to see, are there any factors that are in common in the numerator and denominator? So I factor out this 15b to be 3 times 5 times b, and this numerator I factor to be 5 times 5 times b. So doing that, I can see easily that the numerator and denominator share a 5 in common and a b in common. Again, when we're dividing out, they are becoming 1. This is just a factor of 1. So in essence, it's like we're going 3 times 1 times 1. So we're left with just 3 in the numerator. And on the denominator, we have a 5 and the b right here. So we end up with an answer of 3 over 5b. Here's another example. This example has a monomial in the numerator and a binomial in the denominator. And we're like, hey, do they have anything in common? Well, let's see. 12c, we could simplify that or factor it into factors of 3 times 4 times c squared, or it could be 2 times 6 or whatever. This bottom portion will help us decide how to factor that. So I'm going to look at this binomial. 3c and 6 have a common factor of 3, so I'm going to factor out a 3 from both the 6 and the 3c. So that tells me I have a factor of 3 in the denominator. So I think about 12 again, and yes, 12 also can be factored into something with a factor of 3. So I use 3 times 4 times c squared and over 3 times c plus 2. So I can cancel out this factor of 3, leaving me with this fraction, or this rational expression, of 4c squared over c plus 2. Okay, so going to Another example, now we moved up to the numerator having a binomial and the denominator having a trinomial. We are going to factor both of them, and we factor a little differently, but it's still called factoring. So sometimes that can be a little confusing. It's like, well, factoring can mean factoring out a greatest common factor, or in the terms of the 2x minus 12. So this right here, these have a common factor of 2 right there. So we're going to factor a 2 out of the 2x minus 12. But here, these three terms don't have a common factor, but it is a trinomial. So we're going to factor this out into something, into a product of two binomials using whichever strategy you choose. So what would it look like? So the top, the numerator, if I factor out a 2, I get 2 times x minus 6. And this trinomial factors into x minus 6 times x minus 1. Okay, if you don't trust me, use your FOIL. FOIL this and it should come right back out to that trinomial. Well, as we can see now that both terms, or both numerator and denominator, are factored completely, we do see that they have a common factor of x minus 6, which can be canceled out or divided out, leaving us with 2 times 1 at the top and 1 times x minus 1 at the bottom. So our answer is just 2 over x minus 1. Of course, we could have a rational expression where there's a trinomial being divided by another trinomial, or a trinomial in the numerator and a trinomial in the denominator. Factor both, making both a product of two binomials. Okay, so I factored it. I ended up with c minus 3 times c plus 2 in the numerator, and c plus 2 times c plus 3 in the denominator. Again, these two binomials multiplied gives us this trinomial, and these two binomials multiplied together gives me this trinomial, the one on the top. And we can see they have a common factor of c plus 2. C plus 2. So we can divide those out, and we'll be left with this right here, c minus 3 and c plus 3. And it looks like this. Okay. Now, one more thing about simplifying rational expressions is being able to recognize opposite factors. Opposite factors, when canceling one another out, equals -1. And you're like, so what does it look like? What does a opposite factors look like? Well, let's get an example up here first. Okay, so first of all, if you look closely at this rational expression, we have a binomial over another binomial. In the binomial in the numerator, the x term is on the left and the constant is on the right. In the denominator, the constant is on the left and the variable is on the right, or the variable term is on the right. So they're kind of reversed. So this kind of gives you a hint that we're going to have opposite factors. Right now we may not see what they are, but it gives you a hint that, hey, let's check to see if there are some. So what we do is go ahead and factor both the numerator and denominator. Okay, so factoring both numerator and denominator, I end up getting these factors. In the numerator, 5 times x minus 3, because they had a common factor of 5. And this one right here is a difference of 2 squares. 9 has a square root, and x squared has a square root of x. 9 has a square root of 3. So I can just get this binomial 3 minus x times 3 plus x. So again, take a look closely right here. We have this x minus 3 on the top, and down here I have the exact opposite, 3 minus x. Okay, because in subtraction it is opposite. If I had three, well, I'll just leave that, let you think about it. Marinate that in your head, okay, a little bit. So what can I do? They're not exactly the same, so mathematically, this is what I do. I'm going to divide out a -1 out of this term. So if I divide out a -1 out of this term, that's going to change both of these terms to their opposites. Something like this. So if I divided -1 out of this 3 minus x, I end up with x minus 3, because here we had minus x, now it's a positive x. Here we had a positive 3, now it's a minus 3. Okay, so now I have the factors looking exactly alike. X minus 3 and x minus 3 cancels out, becoming 1. And so now I have 5 in the numerator, x plus 3 in the numerator, and also this -1. Well, if either the numerator or the denominator is negative, it makes the whole fraction negative. So the way we show that is we put the negative in front of the fraction, like so, and write 5 over x plus 3. So it's a -5 over x plus 3. Okay, one more example. Once again, we're trying to see if we could recognize opposite factors. So I told you last time, look at the two binomials in this case. The constant is on the left and the variable is on the right in the numerator, but in the denominator, the variable is on the left and the constant is on the right. So that's giving us a clue that there's going to be an opposite factor. So 8 minus m really doesn't have any common factors right away. But because I said we're looking for opposite factors, we can right now divide out a -1 so that we could make the m be on the left side and be positive, just like this m. And down here in the denominator, we have a perfect square. What is that called? A difference of two squares in the denominator, because this first term has a square root and 64 has a square root. So I'm going to divide out a -1 from the numerator, and I'm going to factor this difference of two squares into the product of two binomials. Okay, so I end up with this: -1 times m minus 8 over m minus 8 times m plus 8. So I can cancel out the m minus 8's, leaving me with just 1. And if I multiply -1 times 1, I get -1. And at the bottom, 1 times m plus 8, I just get m plus 8. So again, my fraction is negative. So to show my negative fraction, I can put the negative right in the front of the fraction and write the numerator and denominator of 1 over m plus 8. So I get -1 over m plus 8.